welcome to this video. In this video, we'll be looking at how to evaluate this limit of a function using series expansion method. In the last video we uploaded, we talked about how to use the differentiating method to evaluate this particular function there. So now, the first thing for us to use series expansion method is we are using the maclaurin series expansion method. Now, the maclaurin series expansion for the sine x, that's the first thing to get. The maclaurin series expansion for sine x is x minus x cubed over 3 factorial plus x raised power 5 over 5 factorial minus x raised power 7 over 7 factorial then plus and so on. Now, the reason why we are to know this is very simple. We are just going to substitute this sine x, this expansion, into this line here, and it is very simple. We are not to substitute everything here into this sine x. We are just to substitute. You can take 2. You can just take this 2 here, and we will still get our answer. Now, to this question, you know, this is for sine x, and we have sine 5x here. So in place of x here, we are just going to be using 5x. That's the key thing there. So here we can now say we have what? 5x. So let's say we are writing series expansion of sine x into this, and we are in place of x, we are putting 5x there. So it will now be what? 5x minus, what is the man here? 5x cubed, that's all cubed, divided by 3 factorial, then all divided by x, because we have divided by x here, and we already know that this 5x, just like x here, it will be 5x, then this x here will be what? 5x all cubed. So from here now we can simplify further by, and we'll be having something like 5x minus 125x cubed divided by 3 factorial is just saying 3 multiplied by 2 multiplied by 1, hence we have what? 6. And we have in bracket. Now, divided by x, turning it to multiplication, we can have what? 1 over x. Now, from here, we can come here saying, if from here now, want to cancel out this x, you can extract or factorize x from this numerator here. You can now say from there, we can say factorizing x out, we have x, then what will be left out here is 5 minus, then we have what? 125x squared over 6, and we have multiplied by 1 over x. Now from here now, x can cancel out x. We are left with 5 minus 125x squared over 6. Now from here, we can now substitute our value for, if we are to substitute this x to 0, we'll be having 5 minus, in place of x, we put 0, we'll be having 125 0 squared over 6. And here, we already know that, from here, we already know that 5 minus anything multiplied by 0, because 0 squared is still 0, then anything multiplied by 0 is 0, then we have 0 over 6. And 0 divided by any number is still 0, hence we say what? We have 5 minus 0, which gives us our answer as 5. Hence, we can say limit of sine 5x over x as x tends to 0 equals 5, using the series expansion method. And using the differentiating method, we dropped the video on, we also got 5, hence you can either use the 2 methods. Now, the key thing is to know the series expansion for the 3 functions given there. We have for cos x as the series expansion for cos x, also we have the series expansion for tan x, and for 1 plus x. So we have all this, that's just the key thing we should know. So that will be all.